Hi, this is Raphael over at NYC Resistor, and I'm going to work on a circuit board mounting platform for the mill. And so I'm going to show you what I have here and why I need to change it. So the first one we made works great, except that the problem is that it's a little too thin. And the reason it's too thin is because in order for us to drill the holes in it in a piece of circuit board material, we would need to get this drill bit mounted into the mill not all the way up to the ring. And so the problem with that is that every time you change bits you need to re-zero everything. So the solution for that was to make one that is thicker. So this one here is about 1/4 of an inch, maybe a little more than that, thicker than the one from before. As you can see here. There. Well, let's get that lined up so I don't have the camera parallax. So you see how much fatter that one is. So this is great and all, but it occurred to me that I'm using these big expensive blocks of aluminum and then attaching a piece of acrylic to the top of that for the spoil plate. Why not just make the whole thing entirely out of a big, fat, thick piece of acrylic? And that's what I'm going to do today. And it should work pretty well. I think any flatness problems, well, that would have happened before anyway with the spoil plate. So we're not adding any inaccuracy to this. This is a piece of cast acrylic instead of extruded, so the two surfaces will be very parallel with each other. And we're going to do some extra features because the material is clear instead of opaque like the aluminum is. Alright, see how it goes. I've milled out some channels.
One is that you need
some holes in
much more
places
than your
here.
average USB
I'm mounting
output to
some
actually power the board
LED strip.
with other stuff. Alright. So
And
they
it should
basically
look
say
pretty
if you're
good.
gonna power.
Here we
Looks
go.
like an iPhone charger. Yeah, not like a normal.
Time warp. So now it's done. I used a milling machine to drill these holes, put these mounts in, make those tracks that the lights go into, stuffed them in, put some tape around the edges to keep it all nice and clean, glued it on, gave it a power supply, and I'm going to attach it to the mill right now. So get it centered. Well, it doesn't really have to be all that close to center, just kind of has to be on there. And it looks like everything is pretty square. Just have to tighten this down, and really what I'm interested in, more than flatness is, more than squareness is flatness. So this is the copper clad board. It has to get mounted onto the board mover here, and that cutter will cut out traces. So I mount it with double stick tape. This is a sort of thick, gelatinous double stick, and I've already got some pieces on here. I haven't taken the backing off yet. I'm about to do that. I'm going to take the backing off. I'm going to stick it down on here, square it up, somewhat, and then I'm going to start driving around, and we're going to see how well we can see through with all that light shining up. You can clearly see the trace glowing up through the board. So this is great. This means that we have verification that we are actually cutting through without even having to really look that close. You don't have to worry about whether or not you're seeing some kind of funny reflection or anything like that. You know for sure that unless the metal is completely removed, you're not going to be getting light through. So, there we go. A backlit printed circuit, well, not printed circuit board, a backlit custom CNC'd circuit board mounting panel. Thank you very much. And remember to wear your safety goggles